And welcome everyone. This is Mr. Cowan to help you out with Chapter 3, Lesson 6, two-step equations, finally moving into the two-step stuff. But first, let's pause for a moment and check your homework from assignment number 21, page 69, 5 to 12, 37 to 45. Pause and come back when you're ready. All right, folks, sorry that's a bit of a mess, but hey, doing the best I can. We all are, aren't we? So today we've been working on one-step equations for quite some time now. 32 plus f equals 143. Okay, what if we have 32 plus 4f's equals 143? Instead of 17 envelopes equals 187, what if we have 17 envelopes and then Mr. Cowan took away $34 and in the end we have 187? So focus for today, today's learning target, I will solve two-step equations. And of course, we'll be moving into 3 and 4 and multi-step as the year passes. So keep that in mind. Go ahead and title your paper. Come on back when you're ready for some examples. Notice I've crossed off 41. I might do a few of those as extra examples if you need any, but go ahead and cross off 41. So 22 to 40 evens. And here we go, folks. I really want to start with just the basics of two-step equations. I'm not convinced you understand the math unless you can draw models. So let's just picture 3 envelopes of money, and we'll call those our missing x values, okay? I don't have to write in the x, but you can if you wish. Then we have 7 extra dollars. Now, if we have 3 envelopes of money with 7 extra dollars, it's equaling 22. All right, wait a second. What part of that 22 has nothing to do with the 3 envelopes? Well, that's the 7. So the very first thing we're going to do is we're going to cancel out those 7. But that's not fair to do it just one side. Remember that every equation is like a balance, a scale, a teeter-totter. So if we take 7 away from one side, we must also take 7 away from the other. So how would we write that with numbers and symbols? How would we write that algebraically? Well, first thing I do is I copy the problem down just as I see it. And then I say, what did we do? We wanted to get rid of that $7 that had nothing to do with the 3 envelopes of money. So we're going to take away 7 from both sides. Naturally, 7 minus 7 cancels out. What does that leave us with? Well, on the left side, we only have 3 x's, and on the right side, you can count them right here. 1, 2, 3, 4, 5, 5, 10, 15. But we don't particularly want to know how much 3 x's are. Our goal would be to know how much a single x is. Now you can imagine where we're heading from here. All we're going to do is we're going to split up and decide how many dollar bills are in each plate. Now, yes, I made the numbers rather simplistic this time so you can see where that comes from. We're going to take 3 plates, or excuse me, I use paper plates when I do this with my 7th graders. We're going to take 3 envelopes, split it into 3 parts. We're going to take 15 envelopes, split it into 3 parts. Where naturally 3 envelopes split into 3 parts is a single envelope. No, you do not need to write the 1. But that's ultimately what we wanted to know, right? And in this case, it appears that our answer, our solution is going to be 5. But of course, how can we check that? We are going to rewrite the equation. 3 times some missing number plus $7 is equal to 22. And we think we know what that missing number is, but I'm going to, of course, put a question mark there. Now, let's get past that fake checking, ladies and gents, and actually do it. In fact, many of you know I cover up this side completely with my hand. 3 times 5 is 15. 15 plus 7 extra is 22. And if I copy this down, now I see it is true. So actually do the checking. Pause if you need, rewind, watch that again to see where those steps came from. Notice I use the colors with the 7 to show how to cross off 7 in my model and how to cross off 7 with numbers and symbols. I use the green with the splitting or dividing. I showed it to you with the model, and I also showed it to you. The green is splitting up the 3 into 3 parts and the 15 into 3 parts. Let's go ahead and do a couple more examples here. I'm going to go ahead and start with example number 1. Feel free to write that down. In fact, many of you should. We're going to start with 8 x's. Subtracting 5 equals 59. So how is this similar to the problem? Well, we have multiple x's. How is it different? We have a -5. So we got 8 envelopes of money. Mr. Callen was kind of mean, took $5 away. Well, what happened before he took that $5 away? Let's go ahead and add that $5 back in. Now, when we do that, -5 plus 5 naturally makes 0. No need to write the 0 out, but that leaves us one step closer to our goal. Remember that our goal would always be to find out what x is, right? So let's go ahead and take those 8 x's and let's divide it into 8 parts. Let's take that 64 and divide it into 8 parts. In this case, 8 divided by 8 cancels out, no need to write the 1, but that was our ultimate goal. How much money is in one envelope? And it would appear to be $8. Now, if I were to go ahead and rewrite my equation, 8 times some missing number, take away 5 equals 59. We don't think that's missing anymore, so let's go ahead and substitute in. Let's cover up the 59. And let's go ahead and simplify or compute that expression. 8 eighths is 64. 64 minus 5 is 59. And look at there. We end up with a true statement. Now let's go ahead and take a look at number 2. Look at how number 1 and number 2 are similar. They both have multiple envelopes of money. They both have a 5, but in this case, we have a plus 5. Over there, we had a minus 5. So how do we get rid of those 5 extra dollars? Well, this is more similar to the example that we did on the previous page, where we're going to have to subtract. Why does that work? Because 5 minus 5 makes 0. Leaving us with 12 envelopes of money is equal to $120. But we don't want to know what 12 envelopes of money are, so let's split it into 12 parts. Being fair and splitting both sides into 12 parts. Naturally, 12 split into 12 parts. Boom, we got a single y. That was our ultimate goal. And in this case, y must be 10, or must it? Let's go ahead and find out. 12 times some missing number, adding 5 equals 125. Let's go ahead and substitute in 10, and let's see if this really does work. Well, naturally, 12 tens, order of operations, let's do our multiplication first. 125 looks to me like it sure equals 125. Now, just some vocabulary terms for you. We call this the variable term because it varies, it changes. X could be 2, X could be 20, right? We don't yet know. But this would be the opposite of a variable term. We call that the constant term. Notice there is no X amount by that number. It doesn't vary. It doesn't change. If you have noticed so far, we always eliminate that constant term first. What part of the 59 had nothing to do with the 8 envelopes? Well, that was the 5. Let's get rid of that minus 5. On the other side, what part of the 125 had nothing to do with the 12 envelopes? Well, that would be the plus 5. So keep that in mind to try to eliminate that constant term when at all possible. As we did on the previous page in red, we got rid of those 7 extra dollars first. Then we were able to split up whatever is remaining. All right, I'm going to give you some minutes. Go ahead and pause. Try to do these examples on your own. Yes, they have decimals, but don't be intimidated by decimals. You know how to compute decimals. Pause your video and come on back when you're ready. So let's go ahead and I'll reveal both sides. Take a look as we talk through number 3. First thing, what part of that $4.20 has nothing to do with the 3 envelopes of money? Well, that would be the $1.80, right? So we take away $1.80 from both sides, and then we take whatever is remaining and split it into 3 parts. That would leave us with a single envelope equals 80 cents. Substitute in and notice that it makes a true statement. In green, example 4, 4f's minus 2 3/10. Well, let's get rid of that minus 2 3/10. Let's add that $2.30 back in. So before someone took any money away, we had 4 envelopes of money equals $8.80, 8 8/10. Now we can split up both sides into 4 groups and find that 2 2/10 would be the solution. If you don't believe it, a solution is a number that makes a statement true. And when we substitute in 2 2/10, we get 6 5/10 is equal to 6 5/10. That's a true statement. Now it looks like I'm about wrapped up, but I will do 3 extra examples if you need. I really think if you understand these 3 examples, you can handle anything in the homework. It's actually going to the problem that I've crossed off from homework number 41, where we have a certain number of books, $16 times the number of books, B, and then there's a shipping cost, S, but notice that's, well, I'll talk about that in a second. And then the cost in total will be C. So what they've asked us to do here, they've given us different parts. So in letter A, they've given us the number of books, they've given us the shipping cost, they have not given us the total cost. So I'm going to go ahead and I'm going to rewrite this, but now I get to substitute in 3 books. And if I look at letter A with the shipping cost, it's $1.85. And here's what we do not know. Oh, no big deal. 16 times 3, 48 bucks. Oh, wait. Don't forget that shipping cost. And notice here, folks, all of the computation is on one side. So there's really no inverse operations to do. We did not have to get rid of any terms. The final shipping cost will be $49.85. Now let's look at letter C, where the number of books is not known. But we do know the shipping cost is $3.45, and the final cost was $99.45. Now this looks very similar to what we've just done. Our target, our goal would be to find out what B is, but what part of that $99 has nothing to do with the 16 books? Well, that would be the $3.45. So let's go ahead and subtract, I'm running out of space here, $3.45 from each side. That leaves us with the $16 per book is equaling $96 exactly. Now in this case, if I split it up into 16 groups, that would show me that a single book, or well, 96 split into $16 would give me 6 books. So in the first problem, we found out the total cost. In part C, we found out the number of books. We'll wrap up part F and then I'll let you guys go. Again, you can fast forward through this if you can handle it. For part F, we know the number of books. We know there are 7 books here. What we don't know is the shipping cost. I'm going to try to make that look like an S, not like a 5. And then we know the total cost is $115.10. So first, what I'm going to do, why write 16 times 7 if I can actually multiply that out? 16, 7, 70, and 42. I hope I do this right. 112 plus some missing amount. Now remember, we can use the commutative property to say, why write that first when we can write the 112 second and write the S first? And now if we subtract $112 from both sides, all that's left or remaining is the shipping cost, which would be $3.10. But look at how all these problems are similar, how all these problems are different. They all have some computation to do. In part A, we could simplify first. And then actually we just simplify from there. Part C had no simplifying, but part F did have some simplifying, right? I would say the totally different dude is part A because, well, everything is on one side. So in order to find C, all we really have to do is compute, do the add, subtract, multiply, and divide. Whereas for parts C and F, we had to use inverse operations. How do we get rid of add 345 with subtract? How do we get rid of add 312 with subtract? And of course, we are fair to both sides. You'll also notice with part C and part F that the variable is on one side together with other terms. I think that's what I'll leave you with, folks. I just wanted to do 3 extra examples for you to understand. Look, our ultimate target is to solve for that variable. Find what C equals, find what B equals, find what S equals. But two-step equations can go a number of different ways in order to do that. All right, now, don't forget, get out a stopwatch, time the number of problems. Of course, today's going to be longer than most days because you don't have any in-class time, and I understand that. I think I timed mine to be about 16 or 17 minutes again. So it's going to be a little longer for today, except I got rid of 41, so that should save you some time. All right, folks, take care, do well, and let's grow.